Hello friends. So in this video lecture, we are going to see about transmission lines and RF systems. So the basics of transmission lines and RF systems. So first of all, what is a transmission line? Transmission line is nothing but it is a mode of communication used to transmit signals from one point to another, like a point-to-point communication. So it requires that is minimum of radiation, minimum of crosstalk, then signal syncing or timing properties, then bandwidth, signal fidelity, all those things. So it should be low distorted transmission line. We always prefer a low distorted transmission line to transmit signals from one point to another point. So what are the parameters we look into it? The first thing is the frequency. And the next one is the loss, attenuation, loss of power. So it is measured in dB at megahertz. And we also just look into velocity of propagation or delay. So we always concentrate on the delayed time. So here that is measured by using velocity of propagation. Then dispersion is also important in this case. Characteristic impedance is very, very important when a transmission line is considered. We use transmission line in our day-to-day life. That is, transmission line is used in all PCBs in the form of printed, in the form of etched lines. When a small etched line acts as a transmission line. So it has to adhere with all the characteristics, it has to satisfy all the characteristics of a good transmission line so that the ultimate thing is that the transmission line should be a matched one. What do you mean by matching? Matching means the input power should be equal to the output power, should be equal. This is done by terminating both the input and the output as well as the characteristic impedance of the line to be equal to Z naught. That is the characteristic impedance of the line. So when you just take off the types of transmission line, we have normal regular rectangular waveguide, strip line, coupled strip line, slot line, micro strip line, coplanar strip line, coplanar waveguide, coaxial lines, coupled coaxial micro strip lines, all this we have. So the diagrams are also shown here. So we'll be seeing in detail about all this in your future lectures. So rectangular waveguide means the cross section is very, very important, or the geometry is very, very important to make it as a transmission line. So nowadays we always go with the microstrip transmission line. So what are the types of transmission line we have seen? That is, all the types depend on the electromagnetic phenomena. So it is actually, it depends, there are two characteristics. One is the base, that is primary components or primary constant, and the other one is the secondary constant. Resistor, capacitor, inductor, and conductor RLC forms the primary constant of a transmission line. In the same case, Z naught and gamma, which are derived from RL, that is RLCG components, are called secondary components. So both the things contribute to the characteristics of transmission line. So what is the definition of transmission line? So it is the specialized structure or system designed to carry electric power from one point to another. So they are used for the transmission of electrical energy over long distance with a minimum loss and with minimum distortion. So it is a best example of distributed network. So we'll see in our next lecture why this transmission line is the best example of distributed network. Thank you.